Hi, I'm Frank Latino, and I'm a product manager for Festo in the electric automation business. And I'm here with my colleague, Daniela Gonzalez.
Hi, I'm Daniela Gonzalez, and I'm product manager for Festo North America for valves and valve terminals.
And today we'd like to go over with you the VSVA FCB, which is a new valve terminal from Festo that's designed to really make easy installations in pneumatic applications to achieve a high performance level in safety. So here we have a simple architecture that includes a Rockwell safety controller with some Rockwell safe I/O connected to the VSVA. The unique feature in the VSVA is integrated into the pneumatic valve manifold. There are modules that have feedback monitoring that can provide information for the safety system that also have redundant control of the pneumatics that would achieve this high performance level in pneumatic applications. And here we just simply have an array of power clamps controlled by two separate zones. So I could shut a zone off here. This may be an operator zone, and where an operator may walk in to do feed parts or whatever, and here you have another zone that's continually running. This is part of the machine cycle.
So in here, like Frank explained, we're just simulating multiple power zones that you would have in machine. This is very common in where you need to have multiple operators or just different things that need to happen at the same time. If you have a zone and then you need to access it, you can shut off the power. Other features that we have integrated with the VSVA FCB are pneumatic features like the soft start, safe exhaust valve, and pilot control valve. So this will also allow you to have everything integrated in one valve manifold, so you don't have any external sensors or any other cables going out of your manifold to control this. So in here we can see the valve terminal, and we'll just go over some of what's happening right here. So we have a lot of LED signals going on right now. So these signals are just indicating whether there's pressure present in the valves or not. So in this example, we have three different power zones, three different safe power zones in the manifold, in one additional power zone that includes the vacuum generator. So for the new design of the valve, we've incorporated accessories like the soft start, quick exhaust valve, and in this case this valve is feeding all of the valves downstream. We can also set up the time that it's going to take to fill the valve by adjusting the flow control here. We also have a pilot control valve per zone. So in this case we just have the different power zones. So if I were to push one of the E-stops, one zone is going to completely stop, and you can see over here how the LED just changed. So instead of having to show the orange LED that indicates there's pressure, it just shows that there is no pressure in this zone. So once I reset the zone, you can see the pressure is back in. So other than these new accessories that were added, so like I said, the soft start valve and the pilot valve, this is what's the improvement to this manifold, but we also have additional accessories that are available that can be incorporated with this manifold. Accessories like pressure regulators, sandwich pressure regulators, flow controls. We also have specific plates that will allow you to supply the pressure to one valve or just a whole zone. And also by adding all this new functionality, you can have a more density of valves. So each power zone can have up to 24 valves. So that will allow you to have up to 96 valves in one whole manifold. So this is really groundbreaking.
Thanks, Daniela. I'd like to continue now and focus on the VSVA valve manifold and what really makes this unique. Embedded in the backplane of the pneumatics side is a hybrid system where some of these modules are connected serially to the Ethernet IP adapter, which will pass critical information over to the Rockwell safety controller for processing for the safety function. So modules such as the soft start exhaust valve and the air pilot control valve, the valve that controls the pilot valve for each of the zones, and also the vacuum generator are all on a serial bus that sends sensor information over to the Ethernet adapter that can get, again, processed by the safe controller. In this case here, the power zones are operated or controlled by the on-machine mount safe block from Rockwell, the 1732 ES module. This module, the outputs of here are providing power for the zones, which provide a safe shutoff for the pneumatic application that we showed before. So the pneumatic functions that we're targeting in this case are safe exhaust and also preventative startup. Okay, and for the programmer in Logix, the important thing is that you can get the feedback information from the VTSA to incorporate into a safety instruction in the Rockwell Safety Guard Logix editor. So if we see here, this instruction CR out is using feedback 1 and feedback 2 from the standard program, and it's taking data from the integrated sensors that I had spoken about before. So in this case, it's monitoring if there's power in that zone and if there's also pressure of the pneumatic valves. So for the valve to operate, there needs to be both a power for the solenoid and compressed air for the air pilot. And without those two, you'll get a fault, and that will prevent the startup in a very safe manner. So, and you can see here in the safe instruction, both outputs are on, and that'll only happen when both feedback 1 and 2 are recognized. Okay, so thank you very much for watching this demonstration. I hope you found it informative.
And for more information, please visit us at www.festo.com and look for the VTSA FCB. Thanks.
Thank you.